Hey all, welcome to the Docker Analogy series. In the last video, we discussed Docker volumes and how it can be used to persist the data beyond the container lifecycle. We also saw an example of a to-do application on the same site. What we discussed in the last video was called volume mount. Let's continue our understanding on the volume mount further, and we will also discuss in this video regarding bind mount and what's the difference between the volume mount and the bind mount. You might have noticed is we were able to mount the container file system in the host file system and persist the data, but we don't know where the data is actually stored. Let's see if we can find that out. Let me go to my terminal. So I'm at terminal here. Let me see if my container is running. So container is not running. Let me quickly run that. So docker run -d -p 3000 :3000 -mount type volume src to do app and target is equals to /etc/to-dos. That's the path, if I'm not wrong. SQLite, yeah, that's the path. --name, let name it to-do app, and image name is /to-do app :0.0.2. So our container is up and running. Let's see if we can access this. Localhost 3000. Yes, I think our data and everything is intact, right? Despite this being a new container, that's because the volume mount is doing the great job. The way we look at the volumes is through docker volume ls, and we know we are storing the data in this volume, but we don't know where this volume exists. So let's see if we can find that out. So if we do docker volume --help, let's see what commands we have. So we know create is for creating a volume. We have used that command in the past. Now next is the interesting command called inspect. Display detailed information on one or more volumes, and this is the command what we're going to use, right? So let's try this command, docker volume inspect. The name of the volume that I want to inspect is to-do app, right? Now this is the place where actually our data is stored. If you look at this is the mount point on the host file system, right? This is where actually the data is stored. I hope that clears the things on the volume mount. Next, we are going to look at bind mount. The bind mount actually helps you share the directory from the host file system, your container. Okay, let's see an example, right? So what we'll do is we have this docker ps, right now we don't know where the data is stored, but it is in the volume created by the docker, right? So let's stop this container right now. To do app, we will look at an example of bind mount. Okay, now here what we're going to say is, now this is my path, right, where my application is present. I want to use this path to store the data. Okay, so the way I'm going to do is docker run -d detach -p port map the port of the host machine to container port, and then -mount type is equals to bind. Now earlier, if you remember, type was earlier volume, now it is bind. The source is current working directory. Okay, the way I'll write this is something like this. I can straight away use the path as well, hard-coded path as well, but we can use this command as well. Okay, pwd stands for public working directory. Okay, and then my target is etc and to-dos, right? This is our path where our data is getting stored. So if you look at this here, right, this is our path, etc to-dos. Okay, Minus minus name is to do app, and then container name is to do app 0.0.2. okay. Now before I run this command, I want to show you something, right? So right now before I run this, we are mounting the current path, meaning this is our source path. Earlier we had given the name of our volume, right? But here we are saying, okay, I want this to be my host system where this directory will be mounted in the container, right? This is the current working directory. This is the path that will get mounted. Okay, that means everything that is present here, okay, or the to-dos that gets created should get created here, right? This is the path where it should get created. Okay, let's see if that happens or not. Okay, so I'm going ahead and running this command now. Bind source must not be empty, so source is not definitely empty. What's wrong here? Okay, so we ran the app and it is working fine. Right now we can see the Docker container has run. If we do docker ps, we can see that our container is running. Okay, and interesting thing is, if you do ls now, you can see the todo.db, right? This todo.db is coming from this path. Okay, so in the container under this path, okay, the host directory that we have mounted is this current directory. Okay, so when the container created todo app inside the container, it got created on the host file system also, right? So if you do cat of host file system, right, you can see right now there is no data stored, right? But let's see, let me refresh this right now. It should not have any atom, which is correct. Let me add some atom 1, atom 2, atom 3, atom 4, atom 5, atom 5. Okay, let me mark some of them as done. Okay, now we have done this. Right now what we'll do is, like, will this container will kill this container, but before we do that, we'll just quickly check the data that we stored, is that present, right? If you look at here, you can see the atom 5 and some metadata regarding the SQLite database. You can see atom 4, atom 2, atom 1, all the atoms are actually stored here. Okay, so what we're going to do is, we're going to kill this container, right? If you refresh this, okay, we are seeing the data. Let's kill this container. Docker stop to do app docker ps is the name. It's to do app, is it? That's what I created. So docker stop docker rm. Okay, I'm going to run that command again. Okay, you can see the todo.db is intact here, right? I'm going to create that container again. Okay, instead of todo app, I'll name it todo app now. Okay, now you can see the bind and everything is intact. So you can see this ETs and to-dos, right? This is my target. Minus name is to do app, and this is the container I'm running. The bind point is still same, right? So when the new container starts, it should be able to remember everything, all the data, because todo.db still exists, right? Let's run that. Container is running. Now if I refresh, everything is intact. You see, everything is intact, right? So let's now go into the Docker file system and let's play around with it, right? The way we can do is docker exec interactive and tty. The container name is to do app sh. So I will be landed into the working directory. If I do ls now, okay, so you can see if I do ls here, all my data is actually present here, which is on my local file system also, right? So if I do control T now, let me open another container, right? If I do ls, right, whatever data is present on my local file system, I can see that on my no, I think this is not the correct directory. Let me go to yeah, so I think this is right. This is happening because we are copying the data in a Docker image, right? Along with this, let's go to etc to dos. right? This is the path which we mounted, right? Now if you see in etc to-dos, like all the data that we have on the local file system, it is getting replicated. The reason is we are mounting this specific path from the host file system into the container. Okay, so that's why if you go to etc to-dos, instead of having todos.db only, we have everything else as well. Okay, because this is getting copied from the host file system. That's the logic behind this. Okay, now inside the container, what I'm going to do is I'm going to create a new file and see if that reflects on the host file system, right? So if I do ls here, these are the files I am seeing, but let me go ahead and create a new file system here. New file, text.txt, insert hello, we are learning more about bind volume mount. Okay, so far this has been very interesting. This has been very interesting topic. Let's save this now. Okay, save this file. I do ls in the container, I can see text.txt, and if I do ls here, you will see text.txt on the host file system, and if I do text.txt, you can see all the data which is present here, right? And it is vice versa also, right? If I create something here, it will reflect because in the container, because we are mounting the same directory. I hope that helps you understand this topic or this specific volume mount. And the bind mount. The another way generally people use bind mount is during the development purposes, right? Because we know we are mounting the entire file system of the host file system, and that can help you debug things really faster, right? So now exited from the app, exited from the container, right? So what I'm going to do is I'm going to kill this container now, and I'll show you another power of this bind mount. So I'm going to do docker stop to do app, docker rm to do app, right? So I don't have any container running, docker ps, So what I'm going to do is, so we have this application running here, correct? Okay, I'm going to run a bind mount, and through bind mount I'm going to run this application without actually creating an image, but through a docker technology. Okay, let's see how can we do this with the help of bind mount. So let's write a command here quickly. So I want to run a detached container with mapping the port. So mapping port with the host container 0.0.1 is my local IP local host, mapping the port with the container port. Okay, let's give it backward slash and move to the next line, and we will set up the working directory. So I want, instead of home node app, I'm going to set up my working directory as app. Okay, then I'm going to use mount. Okay, under mount, what I'm going to do is type is going to be bind. Okay, and then src is okay, this is my current working directory which I'm mounting. Okay, and where I'm mounting, the target is a /app, /app. Okay, so, and I'll explain this again. Okay, and what image I want to run, I can give it a name as well. Okay, let me give it a name as to do src. Okay, I'll give it name to do src. What container image I want to run? I want to run image node 18/alpine. Okay, and then once this container is starting, right, what I want to do is I want to basically start this, right? My code will be mounted, right? With this, my code will be mounted, but once my code is running, I want to run this specific command, right? Which is this, right? npm run dev or yarn run dev. So let's try that command. So sh-c, the command I want to run is yarn run dev. Let's run this. Okay, now it wasn't able to find this image locally. Obviously we never used this one. Okay, so it went to a Docker hub, downloaded the image, started the container. Okay, and ran this command cmd when the container started. Okay, and then we got this container image running. So if I do docker ps, you can see this Docker is running, and if I refresh this, right, you can see I can see this a container, I can see the container is up right now, and then it is working as usual, atom 1, atom 2, right? And how this helps in debugging is, okay, if I look at this if I look at this code, right, if I go to index.js, now if I make any changes in index.js, it is going to automatically reflect in the container, right? Because our file system is completely mounted, okay, and the way we are running application is using nodemon. And if you are not aware of nodemon is a special tool which watches over the changes in the application files, and if we see the changes in the file, then it automatically restart that node service or a node application, okay, so that changes can be reflected without developer having to restart the application, okay. So we have run npm run day, which is using a nodemon, okay. The way to check that is, the way to check if it is really restarting is through a logs command. If you look at docker logs --help, okay, it will tell you fetch the logs of a container, right? So if you do docker logs container, then it will fetch the logs, and then if you use the option -f, then it will follow the log output, meaning it will tell the output, okay. So let's try that. Docker logs -f to do src, right? That was the container name. Now if you look at this, we are seeing the logs now, okay. This is the output we got if we go to index.js, right? Listening on port 3000, okay. Let's make a change and see if that updates, okay. Now instead of saying listening on port, I'm saying server running on port 3000. As soon as I save this, right, I haven't saved this, as soon as I save this, it will reflect, you see, restarting the change, starting the node, and the new output we got is running the server, okay, and your application is still intact, okay. Let's make change in the UI front, right? We have this add item. Let's go to the code, HTML code. We go to static, let's go to JS and app.js, okay. So we have something called add item text somewhere written, right? This is the add item text which is written on the button here, correct? Add item. Let's change this to add more items. I am saving this, and as soon as I save this, I refresh this, you can see add more items. Immediately it refreshes because we are using nodemon and we have mounted the host file system. So as soon as nodemon sees the changes, it automatically updates. And why it sees the changes? Because we have mounted this specific directory. This specific directory has been mounted, that's why we are seeing that change, okay. I hope that really helps you understand the way we are handling, or the way we are using the bind mounts smartly. We studied the volume mount yesterday, and today we studied bind mount. Let's take few minutes actually to understand what is the difference between the two. So if you talk about the volume mount, we know it was managed by Docker. So volumes, we did not have any control over where the data is getting stored. It was completely up to the Docker where to store it, right? The another feature of a volume mount is it is named and isolated, meaning the volume mounts are actually stored in a separate file system without any interference from the user, right? It's stored in an isolated place. Also, it is efficient. So volumes are actually more efficient for storing and managing data. They are often faster and more suitable for production use case, especially when dealing with large amounts of data. Also, it is easier to backup and restore, and it is considered like volumes can be shared among the multiple containers and enabling the sharing the collaboration between the different containers, right? So if you have two containers running, if they use the same volume, right, you can easily share the data between the two. Now let's talk about the bind mount, right? So the bind mounts actually points directly toward the location on the host machine file system, right? We just saw an example. The data in the bind mount is stored on the host and changes made in the container are reflected on the host and vice versa. And we saw an example of that, how we created a file inside the container and got reflected in the host file system, and also we saw an example where we made changes on the code in the host file system and those changes were reflected in the container and our node man was getting restarted. Next is bind mounts are less isolated from the host file system, and if you remove the container, the data on the host is not really protected unless you explicitly manage it. The advantage of bind mount is flexibility. Bind mounts offer more flexibility because they can access files and directories from the host, and changes are immediately visible on both host and the container. We saw an example. Regarding the performance consideration, the bind mounts might have a performance override, especially on a certain platform because they don't have the same optimization as volumes. So that's on the overall on the mounting or a volume mount and the bind mount. I hope this helps you understand and gain the deeper understanding regarding the mounts in the Docker. And if you have any questions, I will give a in the description. I'll share a Google form where you can actually post your questions. Feel free to ask any question. I'll be happy to answer them. Okay, I think let's stop here. Thank you.